Hello Year 8s and welcome to Term 4. So hopefully you remember the very last thing that we did last term, and that was talk about rules, tables and graphs, which was exercise 9b. There's still a handful of you that haven't submitted 9b, so you need to make sure that you get on top of that. Now, I imagine, since we've had 2 weeks off, that a lot of you have forgotten a lot of 9b, which is fine. 2 weeks off is plenty of time to forget. So what I'm going to do in this video is I'm just going to go through again the notes for exercise 9b. These are the same notes that we went through last term. There's nothing new here, but I'm just going to walk through them here. And this is just going to serve as a bit of a refresher. If you feel already confident with this stuff and you're comfortable that you've remembered everything, you can skip this video and go straight into 9c. But I do recommend that you watch just the first few minutes or so, and maybe even just do the first example with me, just to make sure that you are comfortable with it, because you don't want to go into 9c and then realize that you really don't understand what's going on. Okay, so with all that being said, this is an optional video, but I very much recommend that you at least stay with me as we walk through the first example here. So let's talk about straight line graphs. A rule is an equation which describes the relationship between two or more variables. A linear relationship will result in a straight line graph. For two variables, a linear rule is often written with y as the subject. For example, y is equal to 2x minus 3. That's an example of a rule. And y is equal to negative x plus 7. That again is an example of a rule. Now, all of that seems kind of abstract at the moment. So let's go through an example and it will make perfect sense. So we've been given the rule y is equal to 2x minus 1. And we need to construct a table and draw a graph of it. So let's really highlight this thing right here. This is our rule. This right here, everyone, is the rule. And from the rule, we're going to construct a table and draw a graph. So here is our table right here. We need to fill it out based on our rule. So our rule is y is equal to 2x minus 1. And using the rule, we need to fill out this table. So in other words, we need to figure out, well, when x is equal to negative 3, what is my y going to be equal to? To do this, what you do is you sub in x is equal to negative 3 into the rule, and then you'll get your y value out. So let me show you how this works. We start off by writing down our rule, y is equal to 2x minus 1, and then you sub in negative 3 into the x spot. Y is equal to 2. I put a negative 3 in there, minus 1. Remember, these are timesing together. 2 times negative 3 is negative 6. Then you subtract 1 from that, which is going to leave us with y is equal to negative 7. So that means when x is equal to negative 3, y is equal to negative 7. And then you just keep repeating this process for all the values here. So let me now go on to the next one here. Let's sub in x is equal to negative 2 to find out what my y is going to be equal to. So here we start off with our rule, y is equal to 2x minus 1. We sub in our x value, which leaves us with negative 4 minus 1. Y is therefore going to be negative 5. Let's zoom out. So I can come over here now, and I'm going to put negative 5 right there. And that's how you do it. You're just subbing in your x value, seeing what you get out as your y value. So now I want you to pause the video and see if you can do the rest for yourself. So pause it, see if you can do it. So what you should have gotten was negative 3, negative 1, 1, 3, and 5. So we have now done the first part of this question. We have created our table of values. The next thing we need to do is draw a graph of our rule. And to do that, we're going to use our table of values right here. So let's look at this for a second. We've got a table of values. They give me my x values and my y values. Let's take this one for example. This is telling me that when x is equal to 2, y is equal to 3. We can therefore say that this is a coordinate, and it is a coordinate. It's the coordinate 2, 3. Because think about it, what is a coordinate? A coordinate has an x value and a y value. X is equal to 2, x is equal to 2, y is equal to 3, y is equal to 3. So these, all of them, are all coordinates. For example, this coordinate right here is 0, negative 1. This coordinate is 3, 5. Remember just to read off your x value first. So now I can plot all these coordinates. So let's give that a go. Let's start with 3, 5. So this is the coordinate when x is 3, y is 5. So I would come here. That's the coordinate 3, 5. And then we keep on going. The coordinate 2, 3. 2, 3. So x 2, y 3. The next one is 1, 1. 1, 1. That's an easy one. My next is 0, negative 1. So here it is right there, 0, negative 1. So 0 for my x, negative 1 for my y. Then negative 1, negative 3 would be there. Then I've got negative 2, negative 5. Then the last one was negative 3, negative 7. Negative 3, negative 7. Perfect. And as you can see, all of these are coordinates. I could, if I wanted to, write the coordinates of each next to it, but I'm too lazy. And we don't have to, so we don't have to do it. But you could if you wanted to say, well, what's this? Or this one? This is 0, negative 1. They're all coordinates, people. All right. What else do you notice? Do you notice that these dots make a straight line? And what we can do now is draw a line through it. This is where you should be using your ruler, and not doing what I'm doing right now, not using a ruler. And put arrows on either side, because this thing just keeps on going forever. Now, we have just created a graph of the rule y is equal to 2x minus 1. So write that down next to it. This line right here is y is equal to 2x minus 1. That's what the line is. Y is equal to 2x minus 1. That's what it is. So the line is the rule. Y is equal to 2x minus 1. Perfect. Let's keep on moving now and talk about the next thing we have to talk about, and that is special types of lines. The first special type of line we need to talk about are horizontal lines. So again, what we're going to do is for the rule here, y is equal to 3, we're going to construct a table and draw a graph. All right, this is an interesting one, and this is why it's a special line. You would think that I would go about it in the same way, and I do, by subbing in my x values into my rule. But do you notice how there is no x value in my rule? So what that means is that y is always equal to 3, meaning that when x is equal to 2, y is equal to 3. When x is equal to negative 1, y is equal to 3. When x is equal to 0, y is equal to 3. And it just keeps on going. Here it says all points will have the same y value. Y is always equal to 3. And now I can plot this. So this is saying when x is equal to negative 2, y is equal to 3. When x is equal to negative 1, y is equal to 3. When x is equal to 0, y is equal to 3. When x is equal to 1, y is equal to 3. When x is equal to 2, y is equal to 3. Do you see that we get a horizontal line? Please use a ruler, don't be like me. That line right there is the line y is equal to 3. It creates a horizontal line. So whenever you've got something in this form right here, y is equal to something, you know that you've got a horizontal line on your hands. All right. So now we can give things a sketch. So practice sketching the horizontal lines. I need to sketch y is equal to 2. Well, that's simply going to be a horizontal line going through y is equal to 2. So this would be the point 0, 2. Y is equal to 4 would just be one a bit higher up. And it's going through the point 0, 4. This is y is equal to negative 3, so it's going to go through negative 3 on the y-axis. So this would be 0, negative 3. That is how you draw horizontal lines. There's nothing to it. All right, let's keep on moving now. Another special type of line is a vertical line. And vertical lines take this form right here. X is equal to something. And it follows the same logic as what we saw in the previous example. What it means is all the points will have the same x value. So x is always going to be equal to negative 2. It's just always equal to negative 2. So now when we come to sketch this thing, when x is equal to negative 2, y is equal to negative 2. So x is negative 2, y is negative 2. It will be here. When x is equal to negative 2, y will be equal to negative 1. So x is equal to negative 2, y is equal to negative 1. When x is equal to negative 2, y is equal to 0. And as you can see, what's going to end up happening is we get a vertical line. Perfect. So that line right there is x is equal to negative 2. Let's now sketch some vertical lines. So when x is equal to 5, it's just going to go through 5 on the x-axis. So this right here is 5, 0. When it's negative 3, it's going to go through negative 3. So this point right here is going to be negative 3, 0. And when x is equal to 2, it's just going to be a vertical line going through 2, 0. And again, please use a ruler. Use a ruler. And that goes for everything we're doing right now. You should be using a ruler when you're drawing the lines, not like this. All right, the last example we need to talk about. The very last thing. I remember this is what caused some issues. This was a tricky one. So let's give it a read. It says, decide if the points 1, 3 and negative 2, negative 4 lie on the graph y is equal to 3x. We have to decide if these points lie in the graph. All right, let's come down here for a second. It's easy if we can visualize this. Now, you do not need to sketch this to answer it, but just because we're learning here, it's good if we can visualize what's actually happening here first. All right, so here in orange, we have our line y is equal to 3x. There is our line. Now, if we had to create this ourselves, we would have to create a table of values. We would then have to like sub in points. So like for instance, we could do 1 and 2 and say when x is equal to 1, y is going to be equal to 3. When x is equal to 2, y would be equal to 3 times 2 is 6. And then you'd have to plot them all. It would take a long time. So that's why preferably we don't want to sketch it. But just to help us here, it's easy that we have a sketch. And we want to determine whether the points 1, 3, so this point right here, let me use a red. Actually, let me highlight it. We're trying to figure out whether this point right here, 1, 3, is on the line. Well, is it on the line y is equal to 3x? It is. It's on the line. It's lying on the line. You can see it right there. It's on the line. So yes. And what about our other point? Our other point was negative 2, negative 4. Is that point on the line? Well, clearly, it's not on the line. It's not on the line. No. And you can see why it's not on the line because when x is negative 2, I should get negative 6 out. This is negative 2, negative 6. So negative 2, negative 4 doesn't work. It's negative 2, negative 6. Here, 1, 3, that checks out. But again, we don't want to have to sketch it. We want to figure out some way to do it algebraically to determine. So that's what I'm going to show you now. So you don't have to sketch it. That was just to show you what this looks like. What you should be able to do is answer it algebraically, which means the following. What you're going to do is you're going to sub in 1 and see if you get 3 out. So sub in x is equal to 1. So we've got the rule y is equal to 3x, and into our x spot, we're going to put 1. That means y is equal to 3. So that means when x is equal to 1, you get out 3. So that means 1, 3 is on the line. 1, 3 is on the line. Is on the line. Perfect. And that's all there is to it. You're just subbing it in and seeing what you get out. And that's what we can see over here. We just subbed it in and we see what we got out. All right, let's go through the next one. We're going to do exactly the same thing. We're going to sub in negative 2. Sub in x is equal to negative 2. And we're going to see if we get negative 4 out. Now, based on our visualization, our graph, we know it's not going to work. All right, we've got y is equal to 3x. I'm going to sub negative 2 into it. Y is going to be equal to negative 6. So when x is negative 2, y is negative 6. So negative 2, negative 6 is on the line. Negative 2, negative 4 is not on the line. And that would be our answer. So again, you don't have to graph this to be able to answer it. All you need to be able to do is sub it in and see if you get the relevant y value out. But this is actually what's happening here. This is, when I'm doing this question in my mind, this is kind of what I'm thinking of. All right, everyone, that is everything for this exercise. Again, You might have just used this video as a refresher and now you feel comfortable with moving on to 9B, or maybe you need to finish off some 9B questions. Wherever you are or whatever you have to do, make sure that you are feeling comfortable with 9B, and if you're still feeling a bit shaky on it, make sure you come speak to me. All right, I will see you in the next video on exercise 9C.